Hello everyone, hopefully you are able to hear me.
Yes.
Okay.
Yeah, we can hear you.
Okay. So this is going to be our first lab, and actually we don't have a lab at every week. So on our course website, if you look, we only have a lab in certain weeks. So let me open that. So basically, for the first 6 labs, we are going to have a tutorial, and this is going to focus on the project that you are going to do. And these last 2 labs are reserved for you to show your project stages. But this term, so usually we have a couple of TAs, and each TA were previously in one sections lab, but this term I'm going to be in both of the labs, and Mohammed is going to do the grading of the projects. So therefore, actually for these 2 last stages, we are going to do something else instead of coming to the lab session. So we are focusing on the project. You don't need to finish anything and upload anything for the labs. But since we are always talking about the project, attending labs is important. We also have this attendance thing going on. And for the project, actually you have your groups ready now. You are assigned to a topic. For the design stage number 1, we are going to announce it soon. You need to draw the ER diagram based on the description you have for your project. And today we are also focusing on how to draw an ER diagram using an online tool called Draw.io. For the later stages, you are going to refine this ER diagram, talk more about the details of each attribute table, etc. And then you have the implementation stages for the project. We are going to post functional requirements later on, and these functional requirements will have 3 different scenarios for each of the topic. It will be like login as a user, enroll to a course, etc. And to do that, you are going to use Python, and for GUI, it's graphical user interface. You are going to create some graphical user interfaces in Python to support the functionality requirements. And in the final demo at the last stage, you are going to show us the project. And our labs are actually focused on these separate tasks of the project. So for lab number 2, we are going to start using SQL-led Studio to create our database. And then we are going to do some SQL queries. And then we are going to connect to this database using Python. We are going to introduce graphical user interfaces. Eda is asking, will I be uploading these recordings? Yes. So at the end of each week, I'm going to upload the labs, and I'm also going to upload this course material, these slides. And actually, we also have one more document for you to read through. I'm going to send an email about how to download them. Then the last labs, as I said, are for you to show the implementation stages, but these may not be in the course time. We might ask you to upload videos that are showing your project, but for the final demo, it's going to be through Zoom for each of the groups. So let's start with a little summary. Why do we use a database? Let's say I would like to store a bunch of students with their ID, name, and surname. Why not store them in a basic text file? But then if I have lots of students, for some operations like checking whether some student with a certain ID exists in my set or not. For example, if I would like to delete a student with ID equals 401, and if in this text file, if the data is not sorted according to any of these attributes, then I need to scan the whole text file to do some of these operations. if I'm, for example, searching the students whose name start with the letter D, for example, then I need to look through this whole document. And if I have like millions of data, then this becomes inefficient. It might not fit in my RAM, for example. It might be stored on my hard drive, and maybe it is very slow to access this device. Database systems offer methods to quickly access and modify big data. So if I store millions of students in a database, then I have a quick access mechanism to retrieve my items or to modify my items, modify my elements. And I don't really need to know about the details of this quick access mechanism. However, in the lecture further on, you will see, for example, how to use B+ trees to index your data. But using a database system, I don't really need to know the details, but it will support quick access to the data. Another positive side is, in a database system, we can store relational data. Let's say I have my students, let's say in a different set, I'm storing my courses. And in an enrolled table, I would like to store a relational information. And in this relational information, let's say I would like to assign some of the students to some of the courses. For example, student with number 102 is going to be enrolled to a course with the course ID English 101. This relational information could be stored in a different table, and I can set up this table so that whenever I try to insert some new data to this enrolled table, for the student's ID, it should exist as a student in my student table, and for the course ID, that course ID should exist in my course table. So talking about relationships, this is actually a benefit. Whenever I try to enter some data in the enrolled table, I cannot just enter some random ID, for example. That student's ID should be corresponding to an existing student. And it will make our lives easier, because otherwise we will have some data in the enrolled table that doesn't correspond to a student, etc. We are going to talk more about this. Furthermore, with database systems, it can be accessed by multiple users. In the course, in the project, you are going to create local databases, and these are going to be used by one user. But in the real life cases, this database could be uploaded to an online server, and multiple users could operate on this database. And if they are trying to access or manage the same data, database system handles these interaction to prevent failure. For example, maybe if I'm trying to update an existing student's ID to some certain ID, and while at the same time some other user could be trying to insert a new student with the same ID, and some other user could be trying to delete that student with the same ID. In this case, these should be handled so that we don't get any errors. And we can design queries to show or update the data in different views using SQL queries. For example, one such query could be to list the name of the students who are enrolled in more than 5 courses. If it's just a single text file, it's very complicated. You need to do lots of programming, count the students, count how many courses they are getting. But with very simple SQL queries, we can manage such tasks. And to get these benefits, actually, we need to design our database. And while we are designing the database, we actually need to fulfill some goals, some requirements. In the project, you are given this data requirements document now. For each of the topics, you have certain requirements for the data, for the storage, what I need to store. And with a good design, we need to solve these problems without any redundancy. So redundancy meaning that for each student, for example, ID of that student is something unique. I can assign it as the primary key of this student table. And then I have the name and surname, which are not unique. So I could have a student with the same name or with the same surname. If I'm also storing, while storing some enrolled relationship, so I'm just storing the primary keys of these related tables. If I want, I can also store the name and surname in the enrolled table, for example. But then I already know, for example, the student with ID 102, this student's name is Jane, for example. I don't need to really store the name in the enrolled table. It's redundant. Also, if a student is getting more than one course, for example, then I will duplicate this student's ID. Then I also need to have the same name appearing more than once in the enrolled table, for example. So that's what we refer to as redundant. So we don't really need to store the information if we already have it in some of our tables. And to design the database, we are going to use an entity relationship diagram. And in this diagram, we have entities, relationships, attributes. So for each of these elements, we are going to talk about in detail. But this diagram is going to illustrate the logical structure of the database, what we need to store. And there are different styles to illustrate an ER diagram. When you search an ER diagram online, there are different styles, and we expect you to use the one that's introduced in the class so that we speak the same language. Otherwise, in these different styles, sometimes the arrows are appearing different ways, etc. So, similar to your project, we are given a database description. So this is a text file. So maybe somebody asks you to design this database, and these are the requirements you need to satisfy. And we are going to go by sentence and try to find some elements. And while doing that, we are going to also remember which of what element is meaning what to us in the ER diagram. So starting with entity sets and attributes. So entity sets, any object that we need to store in our database. And attributes are the properties of entities. And one important thing is these attributes are going to be something common for that entity set. For example, for a student, when I try to store a student, all the students are going to have an ID, a name, and a surname. But for example, if I also introduce some columns, I also have the option to leave those columns empty. But if I'm leaving lots of columns empty, then it kind of becomes redundant. So in our database, for example, an entity could be a student. And for the attributes of the students, we can talk about ID, name, and surname. Some of the attributes that are unique are used to find a unique line in our dataset. So going back, for example, in our student table, let's say I would like to look at some certain line. And what makes that line unique is called our primary key. So a primary key could be the combination of multiple columns as well. And since the primary key is unique, when I'm trying to delete something, if I delete it according to the primary key, then I know that for sure that I'm deleting the line that I'm searching, for example. We can also delete according to some other specification. For example, I can say, okay, delete the students whose names start with the letter A, but then I'm deleting multiple things. The primary key is used for identifying a unique line there. And for these primary key attributes, we are going to underline them with a solid line. So we could have multiple primary keys or a single primary key, but for every entity set, we expect some primary key. So if there is no primary key for an entity set, then we don't have a way of accessing unique data there. So in the ER diagram, for every entity, we need a primary key. So in the description, sometimes it doesn't talk about a unique attribute. In such cases, for that entity, you can make up some new attribute and use it as the primary key. Or if it is something like a unique data, for example, going forward. So this is our whole description, and we are going to focus on little parts of it. So the description starts like, you are going to design a database for a school. Users of the system have a unique ID number, name, surname, and password. So sometimes it says in the description that some attribute is unique, but sometimes we might omit that. But if it looks like something unique, for example, a phone number could be unique as well, and social security number, without saying it is unique, it might be unique. So according to this description, it is saying that the ID is unique, therefore I need to underline that attribute. And for the other attributes, I'm going to connect them to the entity set user with solid lines. So we need to be careful about these shapes, because if you use a different shape for something else, it might mean some different thing. So with entities, we are using the rectangles in the ER diagram. And for attributes, we are using the ellipse shapes. And each attribute should be connected to exactly one entity set. So I cannot have some attributes connected to multiple entities. That doesn't make sense. And for attributes, again, we are not connecting attributes together. We are connecting the attributes to the entity sets. For some common mistakes, I have some slides at the end. We are going to also talk about those. So other than that, we have the is-a relationship to define a hierarchy between our entities. So with an is-a relationship, we need one parent above the triangle. So we show is-a relationship with an equilateral triangle. And we can have just one parent at top. And the children will be displayed or drawn at the bottom side of this triangle. So in some other languages, for example, there could be multiple parents, but in the ER diagram, there can be only one parent. And the children entities are going to inherit the parents' attributes, including the primary keys, plus the relationship capabilities. Meaning that if the parent is in some relationship, for example, this parent could be the student entity, and student may be connected to an enrolled relationship. In that case, when we have a relationship connected to our entity set, it doesn't mean that this entity has to be in that relation. So it is more like an ability. This entity could appear in this relationship, and it will be the same for the children of this parent. So maybe these are special kinds of students, for example. When we are using is-a relationship, we expect some kind of difference in between the children. And this could be in terms of their attributes or the relationship capabilities. For example, child number 2, for this child, I'm going to store additional attributes. Or maybe for child number 1, I could specify a different relationship. Is-a relationship can have multiple levels. For example, I have my user, manager is a user, worker is a user. And then workers are further discriminated. We have researchers and technicians. And for each of these children, we are storing additional attributes. And also, since we are also inheriting the primary key of the manager table is ID. And for managers, we are also storing name and surname. Additionally, we are going to store some account number and a department name, for example. And remember, we said that there should be some difference in between the children. If this is going to be only about categorization, for example, for a student, I can say, okay, I have different levels of students, beginners, intermediate students, advanced students. But if I'm not storing additional information for these child entities, and if I'm not specifying additional relations for these child entities, then instead of using an is a relationship, I can just include one attribute, for example level, and it could store a text saying that whether this student is a beginner, intermediate, or advanced student. So in the ER diagram or the description, it says that a user could be a student or a teacher. For students, you should also store the amount of scholarship. So this is kind of talking about the types of users. A user could be a teacher or a student. But furthermore, for students, I need to store some additional information, some new attribute called the scholarship amount. Then I need an is-a relationship here. The user is going to appear at top. Also remember, for user entity, we actually have some attributes, but while focusing on certain parts, I'm going to omit these attributes so that it doesn't get crowded. So I have my user at top, it's the parent. For the children, we have them below the is a triangle. And for the student, I have an additional attribute called scholarship. I said that for every entity, we need some primary key, but since the child entities are inheriting the primary key of the parent, I don't need to explicitly show them in this part. So for any entity that is not a child of a parent, I need to specify the primary keys. Then we have the relationships. Actually, when we go into SQLite, everything, entities and relationships will appear as tables because we are storing something inside them. They look like tables. But for relationships, we are actually storing information about multiple entity sets together. We are relating the information in one entity to some other entity. For relationships, we can actually connect as many as entities as we want. But usually the simple relationships are connected to two entities. And we also have some special naming for the relationships that are connected to three entities. For relationships, we are showing them using diamond shapes. And relationships can have their own attributes as well. For example, while storing the enrolled information for a student, so I'm matching students with courses, and in this table I can also store some additional grade for that student. What is the grade that student got from a certain course, for example? That attribute could appear as this relationships attribute. When we are talking about relationships, in the relationships we are actually storing some foreign keys that reference the related table's primary key. For example, going with such an example, let's say we have products, we have categories of products. So for each product, I store a product number, a product name, and a price. And my primary key in the product table is the product number. Then in the category table, I store the category IDs and the category names, and my primary key is category ID. If I have some relationship called in, for example, and this in relationship is in between a product and a category, then I'm actually assigning some product to some category. In the ER diagram, I just show these lines that are going to the entity sets. But in reality, in the table, for the in table, I need two attributes. So one is product number, which is a foreign key that goes to my product table. And the other one is the category ID, which is again another foreign key that goes into the category table, which references the category ID, the primary key of the category table. So we are actually storing some information. We need some columns, we need some attributes for the relationship, but we are not explicitly showing them in the ER diagram. These lines are indicating that we need foreign keys to reference these primary keys. And if some table has multiple attributes as their primary key, for example, in some table I can have 2 or 3 attributes as my primary key, then I need that many attributes as my foreign key, because each of these are going to match the ones in the entity. And in the second lab, next lab, we are going to talk more about these foreign keys and primary keys. But this foreign key aspects, this helps us while we are inserting something into this in table, for example. Then I'm going to check whether this foreign key has some corresponding entry in the related table. Then I cannot enter some wrong data in my in table. It has to belong to some product, for example. With relationships, we have cardinality and participation constraints. Cardinality is talking about how many of one entity could match with how many of the other. Or we can also see it like this: how many times a foreign key could appear in this relationships table. For example, if it is many-to-many relationships are indicated with simple lines on both sides. So these are not directed lines. There is no arrow for those lines. This means that, for example, in our product example, one product can be in multiple categories, and in one category there can be multiple products. So coming back to here, for a product number, that product number can actually appear multiple times in my in table if it's a many-to-many relationship, because that product could be in category drink, for example, and for the same product maybe I can assign a different category to that as well. Reading it the other way around, then we are saying that in any category there could be multiple products. So in category number 1 I can match it with different products. With the one-to-one relationships, we have arrows, and if we have an arrow, it is always going to appear next to the diamond shape, next to the relationship in the ER diagram. In some other style, it appears in a different way around, but in our style, if there is an arrow, it's always pointing towards the relationship. And one-to-one relationships, we have arrows on both sides. So if we look at the example, one product can be in at most one category, and in one category there can be at most one product. Then, for example, for water, if I say that it's a drink, then I cannot assign water to some other category again. But furthermore, on the other side, I cannot have any other product being drinks. So I can assign drink only once to one product in a one-to-one relationship. And because of that, one-to-one relationships are more rare. So, for example, something that can only belong to one entity. It could be like something like a passport. For example, we have users, and a user has passport relationship, and one passport can only belong to one user, and for one user there could be only one passport, for example. A one-to-one relationship example. And we also have one-to-many relationships. In this case, we have one arrowed line, and the other line is undirected. So reading it like this example, one product can be in at most one category, and in one category there can be multiple products. So this is more like the real life case. For example, if one product can belong to only one category, then we are saying that in a category there could be multiple products, but for a product, that product is going to be in at most one category. We are saying at most one category because this product does not have to participate in this relationship. So maybe that product does not belong to any category, but if a product is appearing once in this in list, in this relationship, then it could appear only once because it is at most. With the one-to-many relationships, people could like mistake or forget where to put the arrow sign. So you might maybe remember it with this example. So in this example, one owner could have many dogs, but for a dog, there could be at most one owner. So looking at, we have these leashes of the dogs, and they are kind of like this arrow shape, right? So the arrow appears on the dog's side next to the diamond shape, pointing towards the owner's side. So for one owner, there could be many dogs, but for a dog, that dog, if that dog has an owner, then there is only one owner, or at most one owner. There could be some dogs without an owner, but if a dog has an owner, then it's only one owner. But for owners, the owner could have no dogs, that owner could have just one dog or many dogs. With relationships, we also talk about participation. If there is a bold line appearing on either of these sides, then that means there is total participation for that entity set. For example, with our example, every product should be in at least one category. So there is the bold line on product side. This means that if I have some entry in this entity set for the products, so in my product table, if I have some product, that product should also be in the table of this relationship. And these bold lines could appear on both sides. So for this example, if I have a product, that product should participate in this in relationship. If I have some certain category, that category should be also in this in relationship, for example. And we can mix and match these cardinality and participation constraints together. For example, in this example, if I have a product, that product should be participating in this in relationship. Furthermore, for one product, there is going to be only one category, but in a category, there could be multiple products. So the arrow is on the left side. So this is like the leashes of the dogs. For a category, there could be multiple products, but for a product, there could be only one category. And since there is the total participation on product side, we are actually saying that each product should be in exactly one category. It cannot be more because of the cardinality, and it cannot be less because of the total participation. If I have a product, it should be also participating in this in relationship. And in our description, it says that every student should have one teacher as their advisor. A teacher may be the advisor of many students. And this is only according to this description. So in the real life case, maybe sometimes students can have multiple advisors, but we are designing the ER diagram for this given description only. And for this description, we have this advisor relationship between the teachers and students. And for a student, there should be exactly one advisor, not more, not less. Every student should have one teacher as their advisor. So I have total participation on student side, and this is a one-to-many relationship. We show it with the arrow. With the description, it also says that for each course, you should store a unique course code and an optional description. So this is the first time that we are talking about courses, and we need to store something for the courses. This looks like an entity set. And since the course code is unique, it's underlined, meaning that this is the primary key of this course table. Then it says that every course must be taught by exactly one teacher. On the other hand, a teacher could teach many courses. So if we are talking about interactions or operations, so course must be taught, teacher must be teaching the course. So this is some relationship between our existing entity sets. And again, similarly, we have the cardinality and total participation descriptions. For every course, it should be taught. So if there is some course, that course should participate in this relationship, therefore the bold line. A teacher could teach many courses, but a course must be taught by exactly one teacher. As a result, our one-to-many relationship indicated with the arrow on course side. So I said a relationship could be connected to multiple entity sets. It can be any number, but most of the time it's 2 or 3. And because of that, if it is connected to 3 entity sets, there is this special naming for ternary relationships. It's just a simple relationship, but it is connected to 3 different entity sets. And the only one difference is maybe how to read the cardinality constraints in ternary relationships. For example, let's say while teachers are teaching courses, we need to assign some classes for this teaching operation to take place. If I were to only include relationships in between these separate items, for example, let's say between teacher and course there is some relationship, between class and course there is some other relationship, maybe between teacher and class there is some other relationship, then I'm not actually assigning those 3 at the same time. It might cause problems. For example, a teacher could be assigned to some course, but maybe for that course there is no class assigned, maybe it's forgotten. Such things will cause problems. And if I always need the relation between these 3 specific entities, then ternary relationship is the better choice. So for example, if I have the arrows on each side, it's a 1-to-1-to-1 relationship, a ternary relationship. Then each teacher could appear once, each class could appear once, and each course could appear once in this relationship. And while reading this, for example, this is some other setup. This is like many-to-many-to-one. How to read it is if you omit one side, for example, if I omit the course side, then this is a many-to-many relationship between class and teacher. Teachers and classes could appear many times for a specific course. But then reading it like this, if I omit class entity set, then it means that for a teacher there could be multiple courses, but for a specific course there could be only one teacher. And if I omit teacher entity, then it's in between course and class. A class can be matched with multiple courses, so a class could be used for different courses, but a specific course can be given in only one class. So for a ternary relationship, that's how you read it, by omitting one of the sides at a time. And we also have aggregate relationships. For example, let's say in our example, so we are assigning teachers to courses and to classes. And let's say we have online classes and we don't need to really assign some classroom for that teaching activity. In such cases, if a class is only assigned some of the time, not always, if I assign a classroom only in rare situations, let's say, then I could introduce an aggregate relationship, because in the ternary case, think about the table for these teachers. So for example, I have the teacher's ID and then the class and then the course ID, but for the class, let's say it's online, it's empty. And if for many lines, if I have classroom empty, then it's kind of redundant for me to store the class, because I allocate some space according to my attributes. I expect these attributes to, most of the time, to appear in my table. I have the space allocated, but if I'm not using it, it kind of becomes redundant. So in that case, for example, if I'm rarely using a classroom, then using an aggregate relationship is the better choice. In this case, we have an existing relationship and we surround it with a dashed rectangle, and this dashed rectangle kind of acts like an entity set. So remember, we were using rectangles for the entity sets, and this dashed rectangle is kind of like an entity, so that we can connect it to our aggregate relationship. So in this scenario, teachers teach courses, and sometimes we need to assign a classroom for this teaching activity, not always. To assign some teacher to a course, we use this teachers relationship, and to assign a classroom for this teaching activity itself, we are using this aggregate relationship called in. And in this case, for a teacher teaching the course, I can assign a classroom. So I'm not assigning the classrooms to the teachers, not to the courses, but for the teaching activity itself. Actually, in reality, we are connecting the aggregate relationship to this existing relationship. But in the ER diagram, we are showing it using this dashed rectangle. In this dashed rectangle, there should be only one relationship, because we are actually connecting to this relationship. And the entity sets that are connected to this relationship should also appear in this dashed rectangle. So there can be only one relationship inside the dashed rectangle, because actually we are connecting this aggregate relationship to this existing relationship, but it's a special way of showing it. So Elif says, do we use aggregation for using less storage space? Yes, mostly, but it also has this, so the storage is about when we are considering to make it a ternary relationship. So if I make it a ternary relationship, then I say that, okay, always a class should appear. And if we always need a classroom, the ternary relationship is the better choice, because then I might have some courses assigned to a teacher without a classroom in this aggregate relationship. But if we are not always using this classroom, if the courses are online, for example, we can use the aggregate relationship. And one advantage of the aggregate relationships is that also, since we are connecting it to the relationships, for example, this could be something like this. Okay, when teachers are teaching a course, for example, some manager is inspecting. That inspector manager is not inspecting the teacher, not inspecting the actual course itself, but it is going to inspect the teaching activity. So when we need to connect a relationship to some existing relationship, aggregate relationships are our way of doing it. So other than the storage condition, so if we need to combine or connect some relationship to the activity, to the relationship itself, the aggregate relationship is the way to do it. And here in our description, it says that students can enroll in courses that are taught by certain teachers. In this case, you should store which student has enrolled to which course taught by which teacher, as well as a grade in the range between 0 and 100. So students can enroll in courses, okay, but it's not just the course itself. It says that courses that are taught by certain teachers. So for example, I could have some course maybe that are not taught by anyone. But since in the description previously we talked about that there's total participation on course side. Actually, if there's a course, that course must be taught by someone. So actually that's not the case in here. But while enrolling to the courses, it says that in this case you should also store, so you should store which student has enrolled to which course taught by which teacher. So I also need the connection to the teacher. So actually we are not enrolling to the course itself. So maybe it's the course description in the book. And if there was no total participation on the course side, there could be some courses that are taught by nobody. So since there is now total participation, it's not a thing. But if there were no total participation on the course side, then there could be some courses that are not taught by anyone. And students should not be enrolling to those courses. We are actually enrolling to this teaching activity. So that's some hint for aggregate relationship. So if it is saying I need to store multiple information about multiple relations together, So based on an existing relationship between teacher and course, this teacher is giving that course and a student is going to enroll to that course. And again, we can talk about cardinality and participation constraints for aggregate relationships as well. So with this dashed rectangle, it acts like an entity set. And this is a many-to-many relationship. A student can enroll to many teaching activities, and in some teaching activity, there could be multiple students enrolled. But we are not saying that for every teaching activity, at least a student should enroll. So this is a simple line, but if I make it bold, then I would be saying that, okay, for every teaching activity, there should be some student enrolled to it. Or if I have a bold line on student side, then I'm saying that, okay, every student should enroll to at least one teaching activity. But in the description, it's not the case. So we have just simple lines on both sides. Then we have the weak entities. So weak entities are, again, not as common, because for weak entities, we are actually talking about some attributes, but those attributes are not enough to find some unique entry in that set. For example, going with the description, it says that students can have medical reports. For each medical report, you should store a date and a description. So usually in the real life, that's not the case. Usually in the real life, we have some unique identifiers for a report, maybe a unique report ID, etc. But for the sake of an example, let's say that for a medical report, we only have the date and description. Each student can have many medical reports. However, each medical report must belong to exactly one student. Again, this is kind of a hint for a weak entity. One student can have at most one medical report on the same date. Again, this part is also kind of required for our diagram here, because for a medical report, I have dates and descriptions. I'm storing them, but if I only have the date information, that's not enough. On the same date, different students could take a medical report. I also need the primary key of the student so that I'm able to find a unique entry in this medical report table. So in this case, date is used together with the primary key of the connected strong entity. So in this case, our weak entity is medical report. We connect it using a weak relationship indicated with these bold lines, and it is going to be connected to a strong entity. And we are using the primary key of the connected strong entity, primary key of the student, together with this partial key. So it is indicated with dashed underline to find a unique medical report. And in your descriptions as well, don't try to force something to become a weak entity. So they are more rare situations. So in this description, one hint was for medical reports, we don't actually have a unique information, a unique attribute. We have the date and description. Date is actually not unique for a medical report because we could give multiple medical reports for the same date. Description is also not unique. But if I had some unique report ID, then I don't need to make it a weak entity, because I can find a unique row just using its primary key. The reason that we made it weak was because we are not given a unique attribute for it. And again, for weak entities, to be able to make something weak, we need one-to-many relationship. And for a student, there could be multiple medical reports, but for a medical report, there could be only one student. Otherwise, I cannot use the connected student's ID. If I'm able to assign a medical report to multiple students, then if I have that student's ID, I'm not able to find a unique medical report in this table. So let's give a 10 minutes break and we are going to continue at 2:30. Any questions, problems before we start? Okay, so we talked about weak entities, and with our description it says that users can send messages among themselves. In this case, one side is the receiver and the other is the sender. You should store a text message and a date for each sending operation. Each sender can send to many receivers, and many senders can send to the same receiver. On the same date, a particular sender can send at most one message to a particular receiver. This is actually to show one example of a relationship that is connected to the same entity set multiple times. In the real life case, for a message, we again have some unique information to describe a message without knowing the sender and the receiver, for example, and the date. So for a message, we could assign a unique message ID so that message could become an entity set itself. But in this example, it is saying that to find a unique message, we are using the information about the sender, the receiver, and the date. And we have some not realistic case for the dates. So we are saying that on the same date, a particular sender can send at most one message to a particular receiver. So this is just for this example. But whenever we have a relationship, if we are connecting it to the same entity set multiple times, then we need to also talk about the role of this assignment. So send is connected to user multiple times. It means that I need to store two foreign keys. So one foreign key, and for that foreign key the role is the sender. The sender should be an existing user. And another foreign key, for that one the role is the receiver, and that should also correspond to an existing user. For the message text, I am storing it as an attribute of this send activity, send relationship. And we are also storing this date information. Remember, for a relationship, actually we did not really talk about that. We are going to talk about it in more detail for lab number 2. But for this in relationship, I can also talk about the primary key. And usually the primary key for a relationship is the combination of the foreign keys. So to find a unique row in the in table, if it's a many-to-many relationship, then the primary key is going to be the combination of the foreign keys. So if it's many-to-many, to find a unique row, I need the product number and I also need the category ID. But if it's a one-to-many relationship, for example, in the one-to-many case, a product appears only once in this relationship, but a category appears multiple times. Then the primary key is going to be the thing that appears a single time in the table. So if I know the product ID, I don't need to know the category ID. I can find a unique entry in my relationship. In one-to-one case, each side appears once. So I can choose my primary key as the foreign key that goes to the product table, or it could be the foreign key that goes to the category table. So in the one-to-one case, one of them is enough to make the primary key. In one-to-many case, I choose the one that appears once, and in the many-to-many case, I need both foreign keys. And for the ternary relationships, for example, I need the three of them, etc. So for relationships as well, we are talking about primary keys. But since the primary key is usually consisting of or made from the foreign keys, I'm not explicitly showing any primary keys for the relationships. But sometimes some attributes could be part of the primary key. So in the sending case, if I don't make date a part of my primary key, if only thing that describes a unique line, unique entry for the send table, if the only thing is the sender and the receiver information, then a particular sender can send only one message to a particular receiver. And then whenever I try to insert a new entry for the same sender and receiver, I will get an error saying that this primary key already exists. Maybe the sender is Ali, receiver is Ayşe, for example. If Ali and Ayşe appears once in the send table, and if the primary key is made from sender and receiver only, then I cannot insert Ali and Ayşe to that table again. Because the description says that on the same date, a particular sender can send at most one message to a particular receiver, then I make date my primary key as well for this relationship. And if I were to write the primary key for the send, it is sender, receiver, and dates, the combination of these three attributes. These two attributes are not explicitly shown in the ER diagram. They are shown through the connection to the entity set. But I know that for the user table, I have some primary key, and these are the foreign keys that are referencing that primary key, plus the date information. Then for Ali and Ayşe, if I also add the dates, I can send a different message on a different date, for example. But usually in the real life example, I can just define some primary key for the message. I can make it an entity, then a sender and a receiver for the send operation. Then I can just connect this relationship to a message entity as a ternary relationship. So two of them are going to the user, one of them is going to the message entity set. Then we are done. Then I can assign a different message to different or to the same sender and receiver. I can assign lots of different messages. But this is just to showcase that for relationships, other than the foreign keys, we can have additional primary keys. And this was also to show that a relationship could be among the different instances of the same entity set. Let's also talk about some common mistakes. So when we have an attribute, it should be always connected to an entity set. We cannot connect attributes together. In some other style, there is this option, but in our style in the class, we are not using this. Attributes cannot be connected to entities or any place using tick or directed lines. So we always use this simple solid lines, undirected, not bold. The arrows of the relationships, they always appear next to the diamond shape, next to the relationship. They should not appear next to the entities. Also, we are not connecting entities directly together, right? We need the relationships in between. If I'm using aggregate relationships for the dashed rectangle, there can only be one relationship inside that dashed rectangle. Because in actuality, we are connecting the aggregate relationship to an existing relationship. And if the dashed rectangle contains more than one relationship, then I don't know which relationship I should connect to. For weak entities, we are talking about partial keys. So in the weak entity, I cannot have a solid underline. Solid underline means that this is unique. This is the primary key, right? If I can define a primary key for the weak entity, then that should not be a weak entity. If the date is really unique, if on the same date I can just give one medical report, then I don't need to make this entity weak. Then weak entities cannot depend on another weak entity, because with this weak entity we are saying that I cannot find a unique medical report by itself. I need a student. I need the primary key of the student to find a unique row. But then if I define some other weak entity depending on this, then I'm actually saying that for the address I can actually find a medical report, a unique medical report by itself without needing a student. Therefore, we don't have chains of weak entities. Again, a weak entity, we cannot connect it to a non-weak relationship. So if the doctors are giving the medical reports, I cannot use given by relationship directly to this medical report, because I'm not able to find a medical report by itself. In this case, maybe if I really have to assign a given by relationship with the doctor, maybe it can be connected using an aggregate relationship, because using the aggregate relationship I'm actually connecting it to this has relationship, to this weak relationship itself. So when we combine everything together, that's our ER diagram. And if we know how to draw it, it's really simple to draw it using Draw.io. So now we are going to see how to draw this ER diagram using Draw.io, and if you want you can follow along, and this will be also recorded. You can for now just listen, and then later on you can try to do the same thing on your own. So in our course website we have this textbook and other materials part, and at the bottom of it we have a link to the Draw.io. It's an online software to draw general diagrams, and we are going to use it for our purposes to draw the ER diagram. There is also the desktop versions. If you want, you can also like download and use it on your device as well for different operating systems. But for now, the online version is good enough, so you don't need to download or set up anything, install anything. When you open Draw.io, so if it is the first time you are opening it, it asks where you want to save your diagrams. So you have the cloud options, but let's use the device option. If you want to open an existing Draw.io file, the extension is .draw.io. You can open these files from here again. In our case, we are going to create a new diagram. So let's call it lab 1 example. The extension for the file is .draw.io. Some of the formats are not compatible with editing. So if you save it as some image file, for example, you may not open it back and edit it again. So let's go with the Draw.io format. In here there are different templates, and there is actually an ER diagram template, but it's not following the style that we introduced in the class. So therefore we are going to go with the blank diagram here. And I need to define where I would like to store my file. Again, the name is going to be lab 1 example. So this is on my device. If you choose the cloud option, you can also save it to the cloud. So here we have our workspace in the middle, and we have a toolbar on left and a panel on right side. So if these are not open for the format panel, it's called the format panel, the one on the right side, you can open or close or hide it from here. So Ata says, is it good practice to try to eliminate weak entities by assigning them unique primary keys? Or is it bad because the new unique key would be redundant? So usually when you have a weak entity, it might be hard to define some primary key for it. So you might say that, okay, let's make up some number to make it a normal entity. That's possible. But sometimes we are if we have some existing items already. For example, I already have some students, I already have some medical reports. If I'm trying to put them into this database, maybe I don't really need to make up some new IDs. We can go with the weak entities in that case. Actually, weak entities are kind of rare in the real life, because in real life we can just find some unique attribute for anything most of the time. And weak entities are kind of like rare examples. If you are able to make them not weak, that's okay, that's fine, because the new unique key actually would not be really redundant. But if it is not possible to find a unique key for that, then you don't have any other options to, then you have to make it a weak entity. So hopefully that's clear. So in Dravoio we have our workspace in the middle, so we are going to try to replicate this diagram using Dravoio. We have the toolbar on left, we have lots of different shapes here, and we are going to use rectangles, ellipses, triangles, and diamond shapes. Those will be enough for our purpose, and we are also going to include some arrows in our design as well. And to bring a new item to our scene, we just click on that item. For example, on rectangle, I can just click on this rectangle to bring it to my workspace. And while that item is selected, I can select it with my left mouse button. I can drag that shape around. I have these blue circles around the selected item. I am able to resize that item using these. If you have a mouse with a wheel, if you click and hold the wheel of the mouse, you can drag the workspace around. If not, you can hold the space key on your keyboard and left click and drag to move around the workspace. You have these zoom in and zoom out options here. If you hold the control key on the keyboard and use the mouse wheel, this is also for zooming in and out. And when you want to type something on an existing shape, you just choose that shape. While that shape is selected, you start typing. For example, we had our user entity in the description. So if I type user on top of it, it will appear on my rectangle, and I can then resize it, move it some other place. When you come on top of a selected item, you will see that there are some arrows appearing. But for our purpose, we are not going to actually use them. Sometimes if you click and hold by mistake, it will create an arrowed line. So if you need a line with an arrow, maybe that's useful, but we are going to use some other ways, some other methods to create the lines. And if you click once on those arrows, you have the option to choose some following item. Again, sometimes it might be useful, but if you realize it always connects the arrow to the next item, so the arrow is always pointing to the next item, maybe it's not really helpful in our case. So I'm going to right click and delete this rectangle. And you can also choose multiple items, use the delete key on your keyboard to delete items. So I have my user entity, and I also need the attributes. For attributes, we were using the ellipse shapes. I'm going to click on ellipse. So one of the attributes was called ID. So I will write ID on top of this ellipse shape, and I will resize it, position it in some place. And to connect these, remember, attributes are connected using simple lines. I'm going to click on this line. It will bring the line into my workspace. And for lines, there is the ending and starting points, which is not really easy to tell from the picture, but there is also, if you move the line around from the black position, it will just move the line. But for lines, we are going to anchor them into existing shapes. So therefore we need to move them around using these blue circles. And there's also a slight circle in the middle, which is used for creating curves, but we are not again going to use this in ER diagrams. So if you by mistake click on it, just be aware of it. I have my undo, redo options. I can use the hotkey Ctrl-Z to undo. So I'm going to anchor this to my ellipse shape. Let me zoom in a little bit. For each of the shapes, there are certain anchor points around the item. So on the bottom, for example, on this bottom left corner, if I drag and drop my line to there, that line will always try to go to that specific anchor point. And instead of putting it to some specific anchor point, if you drop the line on top of the item to the center, it will be anchored to the center. So using the center anchor is the better option here. So I'm going to also connect the other end of the line to my user entity. And when I move the items around, they are always linked. So I need additional attributes. To do that, you can click on the ellipse shape again. It will bring a new ellipse shape, but this is not in the correct size. I need to resize it, etc. And then maybe I need to find the correct item in the toolbar. So I'm going to just delete this one, and instead it is easier to duplicate the existing item. So I'm going to right click on the existing attribute and choose duplicate option. So it will create a copy of it with the exact same size. So while this one is selected, I'm going to write name on top of it. This will be for the name attribute. And the hotkey for duplicate is Ctrl-D. So if I use Ctrl-D a couple of times, I will have more copies, and these will be for surname, for example. Let me make it a little larger. So if you want to edit the text, instead of starting to type it from beginning, you can just double click on the text. Then you have the option to edit the text. But most of the time, if you just want to write it from scratch, just choose that item and start typing from the keyboard, and then it will appear on top of the shape. So now I need some lines, so I will choose my existing line, Ctrl-D, and then I will connect these endpoints to the center of my shape, and I will use Ctrl-D again and connect that new line to my attributes. Remember, for primary keys we need to underline that attribute's name, and to do that, if I choose the item on the right panel, I have some options for the selected item. The style is for the shape itself, and I also have the text part. If you choose the text part, if you choose this underline button, then it will make it underlined. If you want to remove the underline, just click it again. And the hotkey for underlining is Ctrl-U. You can use Ctrl-U as well. So let's continue with the is-a relationship. For that, we need a triangle. So I will click on this triangle. It will bring it here, but it's not in correct position, right? I need to make it pointing towards the user. To do that, there is this arrow shape, but if you click and rotate it, so I'm going to first show that one. If you click and rotate it to the correct position, and if you type something on top of it, for example, let me write is-a, if I can manage, that will also rotate the text, which is fine. But if you want to also keep the text unrotated, so I'm going to undo a couple of times. So to rotate it with the text, instead of clicking and dragging the rotation symbol, just click on top of it a couple of times. It makes 90-degree rotations, but it also keeps the text in the normal way. So I'm going to resize it, and going back to here, actually while writing something, you can hit the enter key to go to the next line, And to make the text kind of more centered, I'm going to push it to the next line. So I have my triangle for Ize, and I need two child entities. So I'm going to duplicate the user a couple of times. This is going to be for the teacher, and this is going to be for the student. Then I need to connect these entities to my triangle. I need lines. I will duplicate the lines. This time, instead of connecting it to the center, I might prefer to use the bottom anchors, for example, because if I'm using an Ize relationship, the children should appear at the bottom part. So if I connect them like this, if I by mistake push the student around, I know that it should be the child of the parent. Otherwise, if I connect it to the center, it could be hard to understand. For example, if both student, user, and teacher is connected to the center, then it might be hard to understand whether student should be the parent or the user. So therefore, with the Ize relationship, connect the parent to the top anchor and the children to the bottom anchors. And like if you position it correctly, that's also fine. For students, we need an additional attribute. So I'm going to use Ctrl D for one of the attributes. This is going to be scholarship for the students, and I also need another line to connect the scholarship to the student. Then I have a relationship, advisor relationship in between teachers and students, and I'm going to choose this diamond shape, and on top of it let's write advisor. I'm going to resize it so that it looks kind of better. And in Drawio, it also helps you with some guidelines to position your items. For example, if I would like to align the advisor relationship with the student in certain positions, if it is the middle of two shapes, for example, if it is aligned with some shape, you see some guidelines. So these are also helping for you to make clearer diagrams. So again, I need lines. I'm going to duplicate the lines and use them to connect the entities to the relationships. And remember, for relationships, we can have lines with arrows, directed lines, and we can have bold lines. In this case, on student side, I need total participation, and this is a one-to-many relationship, so this line should be with an arrow. So under style, while this line is selected, I have style options for starting and ending position of this line. It says none for both of them now. If I choose one of them and choose an arrow on that side, I will put an arrow on that side. But remember, I don't really know which point is the starting, which point is the ending point. So I might need to try which one is which. So let's say I put an arrow on this side, and instead of getting rid of that arrow and putting an arrow on the other side, what I can do is, if you right click on an arrow, you have the reverse option. So if I put the arrow on the wrong side, just reverse it so that it appears on the correct side. In our style, an arrow always appears next to the diamond shape, next to the relationship. So I need to also make it tick. So while this line is selected under style, I have the line width. So if I increase the line width, it will appear as bold. Then I need the aggregate relationship for, or actually first I need the relationship between a teacher and a course. Therefore, I need the course entity. Let me create a course entity. And for a course, I need two attributes. And those attributes are going to be course code, which is the primary key. I'm using Ctrl U for that. And the other attribute is going to be the description. And I need simple lines to connect them. I will just get my lines from the existing items. And then I need the gives relationship in between. This is again a one-to-many relationship with total participation. So for the teacher, I need a simple line. But for the course side, I need a tick directed line, which I already have. So I'm going to just use Ctrl D to get a new copy of it. And for enrolling a course to, for enrolling a student to a course that is taught by a teacher, we need the aggregate relationship. And in here, to make the dashed rectangular shape, I'm going to include a new rectangle. So I created a new rectangle. If you try to make this rectangle shape larger, you will see that it overlaps the existing items. So there is some layering going on. The new items are appearing on top of the existing items. If you right click on this rectangle shape, there is the option to push it to the back, or you can also bring it to the front. So in this case, I'm going to push it to back. So it appears behind all the existing shapes here. So I'm going to make it larger so that it contains the gives relationship and the entities that are connected to this relationship. Whether I also include the attributes of those of those entities or not is something you decide. So if you just have gives relationship and the entities that are connected to it, it is enough. But if you want, if you can manage it, if it fits, you can also contain the attributes of those entities as well. This should be dashed, right? I'm going to select this rectangle. On the style panel, I have the line pattern option here. So I'm going to choose a dashed pattern for this rectangle. So for this one, aggregate relationship, I have the dashed rectangle ready. I need the relationship as well. So this is going to be the enrolled relationship. And for that one, I need a grade attribute. So I'm going to get it here. So I need some lines to connect the student to the enrolled relationship. I also need another line to connect a grade attribute to the enrolled. Again, I need some other line. This time I will connect enrolled to... Actually, maybe it's a good time to show it. So sometimes you might manage some positioning so that the line appears as if it is connected to a shape. But if you did not anchor it correctly, when you move the shape, the line will not move. So it might make your life harder. So make sure that you put it on top of the shape. Otherwise, sometimes you might manage some positioning. It looks correct, but when you start moving items around, it might cause some problems. So be careful about that. If you want to anchor the line, make sure that you carry the endpoint on top of the shape. So this time for the aggregate relationship, I'm not going to connect it to something inside the rectangle. I'm going to connect it to the dashed rectangle itself. So I'm moving it on top of there. Then I also have a weak relationship and a weak entity for the medical reports. So I'm going to use Ctrl D to have my medical report entity. Let's resize it a little. And this is going to be a weak entity. To show that this is weak, I need tick lines. So while this shape is selected, under the style panel, we have again the line width. I'm going to increase the line width of my weak entity, medical report. I also need to have a weak relationship in between. This was called has. And this weak relationship is going to be shown with tick lines again. So with a weak entity for the rectangle and also for the diamond shape, we need tick lines. And also, since weak entities are one-to-many, because otherwise if it is many-to-many, it really doesn't make sense, because then you are saying that for a student there could be many reports, that's okay, but for a report, if there can be multiple students, then it defeats the purpose. Then I cannot get the student's primary key and find a unique medical report, because a medical report could belong to many students. So therefore, in the weak entity, you have this one-to-many setup with total participation. The total participation on medical report side is also required, because otherwise, if I'm saying that I might have some medical reports that are not in this relationship, then there is no way of getting those reports, because they are not assigned a student ID, and we are saying that only way to find a unique medical report is by combining the student's ID with the date of that medical report. So for the medical report, I need two attributes. So I'm going to use Control D. One is description and the other one is date. And remember, for text underlining, we had this solid underline. But since this is the weak entity, I need a dashed underline. And unfortunately, there is no dashed underlining option for the text. Therefore, we are going to use this dashed line. So I'm going to click on this dashed line. And one thing to notice is, whenever I bring a new item, it is going to follow the last style that I have used. So let me delete these ones, go here to show what I'm saying. So let me include a new rectangle. This new rectangle has thick lines and it is dashed under style. I can change it, make it maybe something else. I'm using solid lines, but it's thicker. If I create a new ellipse, it follows the last style that I used. So maybe I can make it dashed with smaller line width, and whenever I bring a new item, it is using the last style that I used. So just be aware of it. As a result, when I included a new dashed line, it is now thick. So I need to make it smaller. So I'm going to put this line as if it is underlining my attributes. And like remember, I can anchor or I can position it so that it appears as if it's underlined. But be careful, if you don't anchor the lines to the shapes, when you move the shape around, the line will not move with it. So I'm going to use the undo option. In here, I'm going to anchor this line to the bottom left and bottom right anchor points of my shape. So if I do it correctly, so on the shape, while you are moving the line, there are little cross marks, blue cross marks. Maybe it's hard to see on my screen, but if you drop them to those positions, it will anchor the line to these anchor points. So whenever you move the shape or resize the shape, now it follows the shapes, so that this is like better for us, because while creating the ER diagram, if you don't have like a drawing at your hand from the beginning, then it's really you really need to move the items around whenever you include something else. So I'm going to use solid lines to connect these attributes to the medical reports entity. And the last thing is we have some relationship connected to the user entity, and that's the send relationship. So I'm going to get a copy from here. This is going to be for send. For send, we have two attributes. One is the message. I'm going to resize this one. And the other one is the date, which is also a primary key. So if I duplicate the ID of the user, then it will be already underlined. For these attributes, I need to connect them using normal lines. and I need to connect send twice to the user entity. And if I use the center anchor for it, then it will be using the closest path to the item. So if I have two lines, it will look like as if there is just one line. So if I need to connect it multiple times to the same part, then it's better to use these anchor points around the shape. So I'm going to use the top left and top right anchor points for the user entity, and similarly for the relationship send, I'm going to use the anchor points that are around my shape. So now I am successfully connected, but I also need some text on top of these lines giving information about the role of these foreign keys. And one side is going to be sender and the other one is going to be receiver in this case. To write something on top of the line, similar with the shapes, just select the line and start typing, and that will appear on top of the line. And if you, for example, if I write receiver on top of this one as well, it will overlap. If you want to move the text of the line around while that line is selected, there will be a small yellow diamond shape next to the text. So if you move that shape around, you can move your text as well. So sometimes for lines, you might need to move the text around so that it appears correctly. So I'm using Control button and my mouse wheel to move around my workspace. You can also use this zoom in and zoom out options, and if you hold the space key on your keyboard, you can move around your workspace. You can like choose multiple items together by dragging your mouse button around. If you need to like choose specific items, you can click and then hold the shift key on your keyboard, and then you can select multiple items. Then again you can move them around. But usually if you choose a line and try to carry it, so let me choose student and this line, and if I try to carry these two, it will not carry the connected item. So what I actually try to say is choosing by the shapes is better. So if you separately choose the lines, that will move the lines, but it will break the anchors. So if you choose by the shapes, that's the better option. Or you can, like, instead of choosing multiple things, you can move one by one as well. And at the end, if I use Ctrl S or if I go to File and Save, it will save on top of the file that we created on our desktop. And if you want to save as some other file, you also have that option under File, and then you can like save it as a different file. Maybe you are working on different versions, maybe this is like some version number 2, etc. So you might use different names for those files, and I see the name of the current file on this top left corner. If I click on there, there is the option to save it as a different file. There is also some export options as image files. In our project, you are going to upload the drawwire file, so the file that we just saved, but for some other thing else, you might need to draw a diagram, because like this is for general diagrams, you can draw any diagram with it, and it might be helpful in some other part of your life. So in that case, you can export it as an image file, as a PDF file, etc. So for example, let's export it as a PNG as well. There is this zoom option, so if you increase it, the image size will be bigger. So if it is for print, maybe keeping this zoom will be better. You have like different options as well. When you export it, you have the option to download it or save it on the file on the drive. So this is an image file, but for this image file, if I try to open it in drawwire again, it will not be editable. So for it to be editable, it should be a drawwire file. So let's say we worked on the file, we closed it. Whenever you want to open it back again, so let me, for example, go back and open Drawaya again. Remember, I have the option to open a new file. If I click on open existing diagram, then I'm able to choose my file. For example, it was called version 2, the last one was this one. I can just open back that file and continue working on that file again. And these like rectangular pages are for printing options, so you don't really need to fit your work into one page. So that's for something else, and it's asking whether I need to like save the changes as well. So that's actually it. There's also some color options, but for our ER diagrams we don't need any coloring. Do you have any questions, problems? So we completed this one. So I'm going to be posting the recordings as well, and also these slides. I'm going to send an email for it. And you can also like download this finished drawing on your computers. And for the project's first stage, we ask you to read through your topic's description, and you're going to create something like this. So that there could be like a little more relationships, entities, but it's not going to be like too hard. That's not that complicated. So don't try to complicate the project. It's actually not that hard. So according to the description, just doing similar things similar to what we have done in this lab. Any questions, problems? By the way, while I'm talking, you can just at any time interrupt me, ask your questions. I'm also looking at the chat. And if you don't have any questions, that's it for today. So Seni says, I do not understand, how do we reach the data of specific child of a parent? So actually in the ISA case, so when we have an ISA relationship, the children and the parent are separate tables. So the children are inheriting the attributes of the parent. Therefore, for example, in this case, if the teacher and student is a user, then they will also have the attributes of the user. So the teacher also have an ID, student is going to also have an ID, and these will be the primary keys of these tables. We are not explicitly showing this. So for the teacher, I'm not showing the ID or the name or surname and password, because I already know that because of this is a relationship, they will be inherited from the parents. And for the teacher's table, I'm going to have ID, name, surname, and password. This is just how we show it in the ER diagram, but we actually have the primary keys for those tables. And we are going to, like, while we are creating the tables for it in the next lab, it will be more clear, I think. But this is just for the ER diagram. I hope it's clear.
It's like classes, I think, right?
Yeah, kind of like that. So we are like extending those classes. And while we are extending, the why we do is to include more attributes or to introduce different relationships. Any other questions, problems? Fatih says, I understand that we use weak entity when students don't have a primary key, but here student is a user who has a primary key ID. So weak entity is the medical report here. And for medical report, we are using the weak entity, but students have a primary key. So what you say is not like correct. Students have the primary key. The primary key is inherited from the parent. That's why we are not showing the ID of the student here. It's actually inherited from the parent. But student has the primary key. Any other questions, problems? So if not, that's it for today. And like next week we don't have a lab, but the other week we are going to have our lab number 2. So see you later.
Thank you.
Thank you. See you.